Hello and welcome back to another Out of Spec Reviews video. I don't know if you saw our iWays charging outside on a charger. We're in an office building in Stuttgart with actually friends of mine from ASR. And I promised these guys I would do a video last year on this and we just never got to it last trip. So we're back here. This is one of the most fascinating things about vehicle development. We're gonna talk about a lot of virtual vehicle development things, a lot of ADAS things, and how simulators are such a key part of integrating into the new modern age of engineering vehicles and subsystems. So with the new age of vehicle development, and by no means am I a virtual vehicle development specialist, but I do know some of the best in the world, which shows me how little I know, which is kind of, always great to have experts around. It is really difficult working at a car company to basically book simulator time. For example, BMW has something called the FITS, which is this underground and above ground, just crazy engineering center. They have these, 5, 10, 15, maybe even more €1,000,000 simulators that you could literally park a 7 Series inside of and simulate the whole world around you. That's really good for like total vehicle development and everything is modeled. You have supercomputers running everything. But if you're just trying to tune the brake pedal feel on your next generation blended brake EV, for example, you don't need this crazy simulator. You just need to basically tune the brake pedal and feel it. And of course, building prototypes, driving on the street using physical cars is expensive, it's time consuming, and in some cases actually dangerous. And with production cycles from basically, a 7-year production cycle, really getting close to this 3-year pencil to production timeline that everyone's trying to get to, things just can't be done in the real world. A lot of things need to be modeled, a lot of things need to be simulated. And with basically very expensive simulators with 1 to 3 month waiting lists for engineers to get into in automakers being the largest problem, I would say, to the virtual vehicle development cycle, you have one of two options. You can either go and rent someone else's simulator, which has cost associated with it, which has, of course, time and people out of the office and things like that. Or you can get kind of these crappy little desk things that like we play around with at home when we play video games and do your best. This is a solution that's sort of right in the middle. And this is just my friends run this company. I think it's absolutely brilliant. I want to share with you a little bit about where this fits into the production cycle. And then of course, we're going to actually show you a individual use case, which I think is really useful, which is training safety drivers for autonomous vehicles and things like this, sort of people to watch over the cars, and really, really nice stuff. So let's say you work for a big automaker, you're engineering the next electric car and you want to book simulator time. You can't. Guess what? You could throw one of these next to your desk. So we're not talking 5, 10 million euro dollars. We're talking, 30, 40, 50, maybe 100, depending on the equipment you get, $100,000 for something like this. Something where you could easily put 4 or 5 of these in a vehicle dynamics laboratory office, or you could put them in a ADAS functionality office, and it really doesn't break the bank. But the benefits that it provides are insane because you're getting almost all of the useful feedback you would in this giant simulator for literally pennies on the dollar. So it's a really useful thing. It means more of the engineers will be working in simulators, designing and adapting vehicles real time without long delays. So you get the idea. This goes desk side next to an engineer working on a specific project. It can be adapted for 1,000,000 different use cases. And for example, this one has like a $30,000 brake pedal on it. So you could do really good blended brake pedal adjustments, which is just fascinating. It's full range of movement, fully powered, lots of computing hardware. We'll have Marc from ASR tell us all of the hardware of it. I just wanted to give you the quick breakdown of these types of solutions are going to rapidly speed up the development process, and it's going to make it so much easier to have a better end product, again, in a shorter amount of time. So let's have Marc come in, talk a little bit more about this since he's more of an expert, and then actually I'm going to jump in and act as a safety driver in training, which means we're going to run a virtual model of a city. Randomized things will happen. We'll have certain events where a car runs a stoplight or something's out in front of me, and I'll have to take over safely, and then re-engage the driver assistance system so that, if you're, let's say, about to launch a fleet of autonomous vehicles and you need safety drivers in there either for regulation or for your own safety, you have to train them somehow, and this is repeatable and doable. So this would be like a step one to do it in the simulator, and then you can go out onto the public roads as they're sort of adapted to how you would take over in these types of situations. So let's get Marc, let's talk more simulation and virtual vehicle development. Hey guys, my friend Marc is here with me. He runs ASR. And so we've just gone through a little bit of the simulator. We talked some of the use cases, how to basically shorten development cycles with more access to individuals having more simulators. But how did you get the idea? How did you even know this was a need in the auto industry?
Yeah, good question. Hey, I'm Marc, so CEO and founder of ASR, one of the founders. We had the idea to provide compact simulators for everyone, so to make give an access to simulation for the engineer right next to his workplace, so he can basically change parameters at his model and then make the model experienceable right next to his workplace. So that was the basic idea behind, but there was a huge other problem. So there are so many tools in the different domains of the automotive industry that it's pretty tough to set up the virtual prototype and then make it experienceable. So if you look at the development process, each domain, each department develops its model by itself, and to set everything up, you have to combine a lot of tools, and a lot of interfaces are required. And what we do, we take these tools from the different domains, take these models, combine them into a virtual prototype, and then make it experienceable in a simulator.
Right, so you're taking, let's just say, the ADAS team, the powertrain team, the braking guys, the chassis guys, putting it all into one vehicle package and stuffing it into this.
Right, perfect.
Yeah, pretty cool stuff. In terms of price, we discussed, we don't need exact numbers, but it's so much less expensive than these giant simulator rooms that automakers have been using.
Right, definitely. So there are so huge simulators that are currently used in the automotive industry to make a more realistic simulation experience. But these simulators fill big halls and cost millions of dollars and euros. So what we wanted to give the opportunity with the simulator to have a high immersion driving simulation, a virtual test drive with the highest immersion directly at the workplace. So that's the basic idea.
Yeah, so you're going pretty much as crazy accurate feedback. You can go, insanely high quality sensors kind of like this to really model real world in a package at your desktop. Or kind of what we're thinking is you can make this into a fun device, and we could use it as a gaming. We don't need your $30,000 brake pedal. We can use just a regular off the shelf gaming controller to just have fun at the office. But it's a very adaptable solution.
Yeah.
And it's never going to be one of these 10 million euro simulators, but it doesn't need to be for every application, right?
Right.
Yeah. I
So,
mean, I think it's pretty neat. How is it all working? Because it's pretty complicated. And by the way, this seat has heated and cooled seats.
It is.
It all works. It's got power seats. You can literally adjust. Oh, maybe it's off right now, but you can adjust the seats.
You can adjust everything.
Oh yeah, here we go. It's got seatbelt tensioners that works. It's got ABS modeling in the brake pedal if you choose. It's got literally everything. So walk us through sort of outside.
Okay. Yeah, of course. We have a one-seater shell in this simulator, so it's basically the driving seat. We have a high sophisticated steering wheel and high sophisticated pedals. So,
and what do you mean by high sophisticated?
So they're pretty, of course, high pricing in this case, but you can change the pedal parameters, you can adjust the pedal position, the force, you can adjust nearly every parameter in this setup.
Yeah,
here.
Totally direct drive steering to an electric motor in the back with super high fidelity Just an insane amount. You could hook up, of course, any steering wheel you wanted to this. This is off of an OE car, and so you can actually integrate the paddle shifters, the heated steering wheel function if you wanted to. It's pretty insane.
Yeah, so we have the basic shell, we have the steering and the pedals here. Then we have the belt retractor, which is an original belt retractor, which has been used in several cars, which is working here. We see it later on. And the simulator is built completely closed due to vandalism. So no cable is, you can't pull at the cable, so it's vandalism protected. We have an emergency shut off. In case.
Oh yeah, look at that! I didn't even notice that. So there you go.
And underneath the shell, we have a full motion system, so 3 degrees of freedom, heave, pitch, and roll system, which moves the whole simulator. We have a 49-inch Samsung screen, which is mounted on a special mount for the movement forces.
Yep.
And at the front we have the technical compartment with all the technical stuff.
Is that proprietary, or can you show what's under there?
Yeah, that's proprietary.
But I can at least say it's pretty impressive. And you have a whole cooling strategy worked into this as well.
Right.
Now in the US we would need 240 volt power for this.
110 you mean?
Yeah, it works on 110?
Yeah,
even with the motion?
Everything works on 110 and 230.
Yes. Yeah, okay, nice. That's pretty cool.
And maybe an interesting fact about the simulator too is you need a normal plug, so you don't need 400 volts, or you can use it in the office. That's
you literally
basically
plug it just like this next to your computer.
Right.
I've just never seen a solution like this. I've seen the desk-mounted solutions where people will sit at their desk and they can simulate environments. But this is, you know, what I really want our audience to understand is this is 90% of the way to these big giant simulators.
Yeah, right.
And it just sits desk side, and it's, you know, 90% less cost.
Yeah, that's basically it, right?
Yeah,
Perfect.
it's really a really cool solution. So we're gonna do a little bit, it's a little bit of a quick video, but we're gonna do a little bit of a test mock-up, right? So we're gonna simulate, what exactly are you gonna show us?
Yeah, in this use case, we simulate autonomous driving. So the simulator drives by itself at first, and the driver has to, well, intervene at a certain point. So he has to take over and drive by himself afterwards. So the idea behind this is that we want to support the rollout of autonomous driving. That's the basic idea behind it. And why and how are we doing this? So we train safety drivers of autonomous vehicles in the simulator to intervene in critical scenarios.
Yeah, it's a really cool, one of a million use cases you can use this for.
Right.
But I think it relates directly to our audience. This is not training an algorithm to then be a better driving assistance system. That's done in the real world or through however the automakers need to.
Maybe integrated via our platform in the simulator.
Sure, absolutely, it certainly can be. But let's just say you want to roll out 100 cars in a city. You're an Argo AI, you're a Cruise, you're a whatever, and you feel like you either by regulation or by yourself need to put a human behind the wheel. Better than just throwing them out in a car and saying good luck, you can put them in here first and say spend 12 hours, something a really hard task, taking over and not crashing. So I'm gonna pretend to be that person. I'm not so good at this, but I'm gonna sit in the seat and try to avoid situations from coming up. So let's give it a go.
Yeah, sure. Maybe one last point to mention. So currently there's no regulation really. What is a safety driver? What has a safety driver to do?
Right.
But one point is for sure the operator of the autonomous vehicle is responsible for it.
Mm-hmm.
So when you use these kind of simulators to prepare or train your safety drivers, it is possible to create a report out of it and to show, hey, we did our best to train our drivers.
Right, yeah. And then, you know, I mean, it's not even worth going through all the use cases, but if you're a chassis dynamics engineer, you want to look at, okay, what if I put a, you know, more aggressive compound on my tire? Or if I'm looking at battery thermal management systems and you have your vehicle modeled, for example, I can do one Nürburgring lap with this size cooling before it starts to derate, or I'm going to go rip it around again and drive it, you know, differently. and you can really model all of these things in real time without needing to get test cars out on the road, which just adds cost and safety issues and everything. So really, I think great to have as much simulation as possible in the vehicle development cycle, and this is what enables it, because automakers just can't afford a 10 million, 30 million euro simulator in every office room.
Yeah, that's pretty much it. And the offices are way too small for that, right?
Yeah, exactly. Yeah, budgets are tight, and so this fits right in with what people are looking for. All right, well, I'm going to hop in here.
Sure.
And so let's see how this all works. So we got the seatbelt unbuckling. I have my little stool to get in, which is nice. Nice little handle built right into the unit as I slide in. And you can really put, whatever production steering wheel, whatever production seat you're in, or you would like in here. So what I'm going to do is buckle up just as if I was in a normal, series production car. There I go. Feel like I'm driving just a normal car. You might be able to guess, but just a normal car.
All right, now I'm gonna start it via our graphical user interface. So we selected a pre-configured scenario, push the play button, and now the simulation starts. In this case, we have a car maker simulation for the street logics in the back, and it's calibrating, so give it a second. And in the front, we have the Unreal Engine. So that's what you can see.
That's what we're physically looking at. But again, this isn't meant to be like a high quality gaming interface. What we're trying to do is simulate other cars going around. So here, the simulation just starts.
So the sound is turned a little bit low.
Yeah, we have the sound down right now, but that's okay. So basically, I'm just going to pretend to be a safety driver. So I'm going to sit here like this, and I would take over just like I would in the real world. So let's see what happens. Just cruising down the highway. Hard throttle. Not sure I would want this ADAS system on my own car. It's a bit aggressive on the acceleration, but that's not what we're trying to measure. So here we are taking an exit. It's slowing down nicely, no issues for me. Everything is okay. Making a turn, continuing through, trying to keep my eyes up. Whoa, Tesla Model 3 came pretty close there. And is it possible to integrate VR into this?
It is possible, yes. Unreal offers this solution already. And the simulator already has VR glasses integrated.
The movement, I can feel the gear shifts. Oh, it went a little bit to the right. Nice, and stopping because I saw this guy turning.
Very good.
Yeah, so there, I saved a collision. I guess next time what I'll do is I'll just merge us back around here. We'll see if it takes back over.
You have to drive by yourself now.
Oh, drive by myself now? Okay. Until when exactly?
In this case, the scenario stops once you intervene.
Okay, so that was a successful scenario.
Yeah, right. So now the report is created, you passed the scenario.
Right, and anyone can create any scenario they would like, I guess.
Sure. Well, we're pretty flexible.
Look at the lift kit on this thing. Monster Truck Model 3, let's go catch up. Woo. Oh, the seatbelt really grabs, which is crazy. So, this is really quite interesting. This guy's just stopping in the middle of the road. We'll just, don't mind me.
That's a good thing in simulation. Okay, now the simulation stops.
Yep.
So, all right.
Yeah, so let's do it one more time. I'm going to let a collision happen.
Okay.
And yeah, I mean, this is just basically a simulation that you created to showcase the simulator.
Yeah, that's
this is not
demonstration scenario, right?
Yeah.
So, of course, in this case, we can integrate the original vehicle models that our customers have.
Right. If, for
and
example,
the 80 functionalities behind. So
yeah, I mean, if you're going to use a Volkswagen ID3 with your own specific sensor kit on there, let's just say as an example, you could fully digitally model an ID3. You could fully digitally model how their sensors would work, how the takeover strategy works, and then the driver could sit here almost as if it was real world. Again, you're hitting them with sort of known, repeatable circumstances or totally random, and then you can go out on the road and practice the same thing. So here we are, heading out taking the exit. And again, I'm gonna let an accident happen whenever it's going to. And you'll see the seatbelt tension on me pretty hard to simulate a collision. I gotta say, it's so interesting feeling the gear changes through the movement. It's very precise. On the brakes. Feel the whole thing pitch and roll. Okay, here we go. Same situation as last time. And so it had a collision and it braked and it grabbed my steering wheel and now I'm taking over essentially. Oh no, I'm not taking over. There we go. Now I'm taking over. Now I can drive like myself around the city. Which is normally just...
God bless, there's no police simulator, right?
Right, exactly. So you could drive like crazy, which is, you know, obviously fun. Every time you slam on the brakes, the seatbelt gets tension. We're chasing this guy down. Whoa, tree, car. And this is not really meant to be a driving simulator. You can also run Assetto Corsa or any sort of driving simulator that you want on here. All right, stops. Yep. Great. Well, I really think it's cool to be able to show our audience this. I've obviously played around with this for a couple of years now, something like this, 1 year, and have seen the improvement of the quality of everything. Just the fact that it all works. The price, I mean, I just can't imagine, like at this point in a vehicle development cycle, how everyone doesn't have one of these. I'm not quite sure. Because I even think we should get one.
Mm-hmm. Sure. Yeah, you should have one in your office, huh?
Yeah, I mean, I think we should. It'd be good just to, I mean, we even had a use case where we had some of our guys in here earlier today where they, you know, we're just playing a racing game, but we were doing actually some driver instruction, which is get the brakes on the tires in a straight line and turn in it, but we don't have to do this in the real world. So it's really safe for things like this.
I see several use cases, even just getting to know the racetrack or the track in totally. Just simulate the track, see, okay, how to turn left, right.
Not sure we need something this crazy for that.
Yeah.
So but I kind of want something that crazy.
It's just a basic idea, but you can improve the complexity of the simulation, the use cases, and the system is so flexible we can adjust every hardware component. So
if
integrate original hardware.
If someone wants to buy one or 100, how do they get in contact with you?
Yeah, just get in touch with me, Marc Strobel from ASR, www.asr.minesimulator.com. So asr-simulator.com and or hit me up via contact@asr-simulator.com. So.
Great. Yeah, we'll put all the links in the description for you. Can't thank you enough. I'm so thrilled that we're able to finally showcase this. I've been wanting to show this since last time, but we couldn't get the scheduling done. And now, finally, truly an insane piece of hardware. Thanks for watching another Out of Spec Reviews video. See you on the next one. Bye-bye.
Bye, guys.